Hello and welcome to MLOps Minutes. In the previous episode, we initialized a Git and associated it with a remote on GitHub. And now we can already set up our first continuous integration with Github Action. So the idea is to have our branch in hand and protect it so that it's always producible. And to achieve this, GitHub Action will enable us to perform a whole range of automations to validate that it works all the time before merging. Let me quickly remind you of the pipeline. We're going to play with the unit tests of reusable packages, building common packages between training and production, run unit tests on our training, tag the version we want to deliver. We're going to train our model and validate that the statistics are correct and allow us to go into production. Build our Docker with the last model generated, which we'll deploy on a production ISO environment. And finally, we'll run integration tests to validate that we have exactly the same statistics in training as in production. This ensures that we have the same data pipeline between training and processing and production. So we're just at the beginning of our project. We've only put in a demo.py file. And here I have an Actions tab. I can click on it, and GitHub detected that it was Python. So it offers me lots of predefined templates. I'm going to click on this one, Pylint. We won't go into details about Pylint, but the idea is just to set up a GitHub action. And here we can see that GitHub suggests creating a YAML file in a .github/workflows directory. So by convention, CI/CD pipelines are stored in .github/workflows, and they're automatically triggered. So to trigger this continuous integration, if you put on push, it's going to play every time. But that's not exactly what I want. So what I want is to copy and paste it from a file. I'd like it to trigger only when we push directly on main or make a pull request to the main branch. Next, we're going to play a series of actions on the latest version of an Ubuntu type OS. There's a little bit here that lets you say we're going to play all this 3 times on 3 different versions of Python, but that's not what I want at all. I want to freeze the version of Python so that it's exactly the same between training and production. So I want a version of Python. So I'm going to freeze the version of Python I'm waiting for. Then I'll copy and paste this version. So before, I forgot to say, line 13 here, there's an action checkout. Basically, we're making a Git clone of our project. We install the Python version. We'll update pip and install Pylint. That's it, pip install Pylint. And finally, we'll run Pylint on all my Python files in my Git. So there's just one. I can then commit my change. So normally you put a good commit name. And now GitHub has detected my workflow. As I've committed directly to main, it's going to play, it's going to execute it, and it's going to start retrieving an Ubuntu, install Python, and redo all the steps defined in workflow.iml. You can see here in the code that I've created the .github/workflows directory. So we'll let the GitHub action play itself out. And now it's in error because Pylint sends me a missing docstring module message. We can customize Pylint's rules later. But basically, if I take the code here, what do I need? I need to add a comment at the very top of my file. So at the end of the previous episode, when we were initializing the Git, I pushed the same code on the remote demo 2, which was called Toto. And now I'm going back to my branch my demo un, which is on main. So I did this git pull setup stream command. I got back on origin, which was linked to demo 1 and on the main branch directly. As a result, it retrieved my .yml file that had been created and my directory, and I can see my workflow that's been created. I correct my file. I can do a git add dot or a demo.py. We'll do a demo.py instead. Git commit -m fix comment demo.py lint. We'll see later. And now I can do a git push to push on my GitHub branch, my code directly to main. That's it. GitHub has detected my file change. What's going to happen is that it's going to relaunch a build, which this time is going to be a success. It will be open because I normally meet all the clean code conventions required by PyLint. On this file, it's now installed. We're going to install the dependencies. We'll wait. It'll be quick, I think. Here, it worked. As you can see, my build is now open. And now, what's interesting and very important is to protect my main branch. Here, I've made a git commit directly to my main branch, but you almost never do that. Here, I'm going to go to Settings Branches. And what I'm going to do is add protection rules to my main branch. I'm going to make it mandatory to have a pull request and a minimum validation from a colleague to be able to leave, to be able to merge on the main branch. I'll also want us to pass code checks. Before we can merge. Typically, if I take my CI/CD that has just been executed, I can select it. This means that if my CI/CD is not open, Github Action will refuse to let me merge on my main branch. So I protect this branch. It asks me for security validation. I validate. Now my main branch is protected. I'm happy. What happens is that if I take a piece of code that isn't clean and I go back into my code here, what I'll do is replace this file with imported code after a print code that won't pass to PyLint. As a result, I can create a branch, git checkout -b to create a new branch, and I'm going to call it demo rules main. It's not very pretty, but what I'm going to do is I'm going to do git add demo.py. I'm going to do a git commit -m, and as a comment, I'm going to put break demo .py, and I'll do a push of my new branch. So it tells me I want to push on this branch. I put the upstream on this branch. That's what I do. Now that it's done, that it's pushing, GitHub will offer to create a pull request because I've protected my main branch. So I'll be able to make that pull request. And since I've created my pull request, what's going to happen is that GitHub will automatically see in its rules that my build, my CI/CD must be played. What it will do is that since my CI/CD won't go through, and on top of that, I don't have a colleague's validation, I won't be able to merge my pull request. As a result, it's really perfect. This is what I want. I want to protect my main branch from unclean code. I want to respect customizable clean code rules. There, I've failed. As a result, I'm now in red. I can't merge my code on the main branch. And I'm very happy because that's exactly what I want. It's a series of automations to protect my main branch, which has to be prodable at all times. So I can see that he's not happy. My line is too long. I don't have my comment on what the file does. And I've got a contribution that's placed after some code. It's perfect. Thank you and see you soon for more videos.